Welcome to this explainer. Okay, if you've spent literally any time around modern AI lately, I guarantee you've heard the acronym RAG thrown around. Today, we are going to dive deep into Retrieval-Augmented Generation. This is the foundational architectural pattern that makes modern enterprise AI systems actually work. We're going to take this from first principles all the way up to production-grade architecture.
We've got a lot to cover today. We're going to hit the LLM memory problem, the RAG solution, core architecture, advanced retrieval, production reality, and wrap up with the future of AI. Let's just jump right in.
All right, Section 1, the LLM memory problem. Or more specifically, what they don't know.
Look, large language models are incredibly powerful. We all know that. But they have massive, glaring blind spots. Out of the box, they don't know your company documents. They don't know recent events, internal databases, or your private customer data. And because they inherently lack all that specific context, they hallucinate. They confidently make things up. They rely on outdated training data, which creates massive compliance risks. I mean, in an enterprise setting, guessing is flat out dangerous.
Which leads us to Section 2, the RAG solution. This is how we connect these powerful models to actual verifiable truth.
So think about traditional search engines. They act kind of like a librarian who just hands you a giant stack of books and says, "Good luck, your answer is somewhere in there," right? RAG, on the other hand, is like having an expert who reads those specific books for you and synthesizes a custom grounded answer. Instead of just dumping 10 PDFs on your desk, RAG explicitly tells you, hey, based on the policy updated last month, you can work remotely 3 days a week. It's this incredible, intelligent reasoning layer sitting right on top of your search.
So how in the world does it actually pull this off? Let's open the hood for Section 3, core architecture. We need to look at the exact anatomy making this possible.
Okay, we really need to pause here because this is the absolute magic of the system. Embeddings. I know, it sounds super intimidating, but essentially an embedding model just translates text into math. It creates a numerical representation of your data in this high-dimensional vector space. And what that actually means for us is that the system understands the underlying meaning of a sentence, not just basic, rigid keyword matches. Semantically similar sentences, they end up clustered together mathematically.
Let me give you a quick example. Take the phrase, "How do I reset my password?" versus "forgot password recovery." Now, those share almost zero common keywords, right? But they map to the exact same mathematical neighborhood in a vector database, because at their core, they mean the exact same thing. This is how the system actually knows what you're really looking for.
But wait, before you could embed all your documents, you have to physically cut them up. You literally cannot just throw a 500-page PDF into an embedding model. You have to break it down into smaller semantic pieces called chunks. Why? Because an LLM's context window is limited, and retrieval just works infinitely better on highly focused, bite-sized information. Listen, bad chunking will absolutely destroy your RAG quality. If your chunks are too big, the specific context gets lost in the noise. If they're too small, the answers get totally fragmented.
Okay, so if we zoom out and look at all these components together, the embedding model, the vector database, the chunk data, how does it actually orchestrate when a user types in a prompt?
It's actually a beautiful loop. Step 1, the user asks their question. Step 2, that query is instantly converted into an embedding, and the system runs a similarity search in the vector database. Step 3, it retrieves the absolute most mathematically relevant chunks of your documents. Step 4, it takes those specific chunks and injects them directly into the prompt right alongside the user's original question. And finally, Step 5, the LLM reads all that injected context and synthesizes a highly accurate, cited answer.
Boom, perfect flow.
But honestly, fetching those perfect chunks to begin with is arguably the hardest part of this whole thing. Welcome to Section 4, Advanced Retrieval.
Because let's face it, relying on just one way to search isn't going to cut it for complex enterprise data. We just talked about dense retrieval, which uses those semantic embeddings. But sometimes you actually do want exact keyword matching, like if you're looking up a very specific product ID. That's called sparse retrieval. Modern, robust enterprise systems use hybrid retrieval, which blends both together. And the really cutting-edge stuff, they're using graph retrieval, actually mapping the complex relationships between documents to find the absolute best data. Now, once you retrieve that data, your prompt layer becomes your ultimate safety net. The LLM needs strict boundaries. Strong prompt engineering totally constrains hallucinations by explicitly telling the model, hey, answer only using the retrieved context. You can even force it to admit insufficient information if the answer just isn't in those chunks.
you enforce citations. This is exactly where you transform a wild, creative LLM into a strict, reliable enterprise reasoning engine.
All right, time for a reality check. Section 5, Production Reality, the harsh truth.
Because look, building a basic RAG demo on your laptop over the weekend, super easy. Pushing that exact same system to production, that is a totally different, brutal beast. This is why most demos completely fail when they hit the real world. You're suddenly dealing with stale embeddings, like when a document gets updated, you have to re-embed it. You get ingestion failures, retrieval latency that annoys your users, and massive, massive scaling costs. And critically, access control. A basic employee query absolutely shouldn't retrieve data from the CEO's private HR files. Managing those permissions at the vector level takes serious engineering discipline.
And to survive that production reality, you absolutely unequivocally must implement an observability layer. You literally cannot improve RAG without it. You have to be ruthless about tracking your token usage, monitoring retrieval latency, and constantly evaluating hallucination rates and retrieval precision. Seriously, if you aren't measuring it, you aren't managing it.
So, where is all this heading next? Section 6, The Future of AI, Beyond Basic RAG.
RAG is rapidly evolving from just a neat little feature into the core infrastructure of enterprise AI. We're moving fast toward agentic RAG, where AI agents dynamically decide for themselves which retrieval tools to use based on how complex your question is. We're seeing multi-model RAG systems that can process images, audio, and video right alongside standard text. And we're moving toward continuous learning pipelines, where the knowledge base basically updates itself autonomously. It's wild.
Which actually brings us to the biggest, most crucial takeaway from this entire explainer for anyone building AI right now. The biggest mistake beginners make is thinking the model is the product. In reality, the architecture around the model is the product.
RAG absolutely proves that orchestration is everything. The real value isn't just having access to a large language model, it's how you connect it to truth, how you retrieve that truth, and the entire system you engineer around it. So the one vital question I want to leave you with today is this. As you design your next system, are you just plugging into models, or are you actually building the intelligent architecture of the future? Thanks so much for joining me on this explainer. I hope this deep dive gave you exactly what you need to get out there and start building.